Hey, what's up everybody? Welcome to the 25 concept summary videos for SAT Math, and today we are going to talk about system of equations. So in system of equations we will see that there are only two concepts which can be tested. The first one is solving a system of equations. Second one is types of solutions. Now, when it comes to solving a system of equations, there are three methods that you should know: substitution, elimination, and graphing. I'm not going to discuss the method of graphing because you can straight away, you will have the access to a graphing calculator on your digital SAT and you can just plot the graph of the equations on your Desmos. So I'm not going to discuss the graphing method, but I'm going to discuss substitution and elimination because you can get a problem in which they ask you to solve the system of equations, and in some systems you will need to use substitution, and in some of them you might need to use elimination. Second thing is we will see types of solutions. So let's get started. Okay, so I'm gonna take two questions. Here I have a system of equations, and before we start how to solve the system of equations, how will you actually determine that this particular question is testing you on the concept of system of equations? Well, it's very simple. Whenever you see two equations like this, you should you should make sure that this question is actually testing you on system of equations, because you have two equations, so that makes a system of equations. Now in these two questions you have to find out the solution of the system of equations, and for that you can use two methods, as I said: substitution or elimination. Now the thing is, but how will you decide that whether you have to use the substitution method or elimination? Well, in this type of system where your one variable, so here if you see this variable y, this is clearly expressed in terms of x. Y is equal to 2x. So your y variable is alone on the left hand side and all the x terms are on the right hand side. So it could have been also like this: 2x minus 4. So in this type of system of equations, it's really easy to use the substitution method because you already have the value of y in terms of x. So all you need to do is you need to substitute the value of y in place of y in the second equation. So I'm gonna substitute y equals 2x in the second equation. So we have x plus 2y equals to 5, and instead of y I'm gonna write 2x. So 2 times 2x gives us 4x. X plus 4x is 5x. So x is equal to 1. So this is the value of x, and value of y will be, y is 2 times x, so 2 times 1. So y is equal to 2. So the solution of this system of equation is 1, 2. And you should also know that what do we mean when we say that the solution of this system of equations is 1, 2. This means that now if you substitute x equals 1 and y equals to 2 in either of these two equations, then the equations will become true. That means the left hand side will become equal to the right hand side. You can also verify your solution. If you put y equals 2 in the first equations, you get 2 on the left hand side, and on the right hand side you have 2 times x, so 2 times 1 is 2, so 2 is equal to 2. That means our solution is correct. Let's also put it in the second equation. So we have x plus 2y, so 1 plus 2 times 4, sorry, 2 times 2, so 1 plus 2 times 2 is 4, we get 5, and on the right hand side as well we have 5. So 5 is equal to 5 is true. So that means our solution is a correct solution. Okay, so in this type of system of equations you can use substitution method, and as I said, you could have also used substitution method if instead of 2x you had something like 2x minus 4. Even then you could have used this method. But this method, the method of substitution, does not work in this type of system of equations. Well, it can work, but it will actually take a lot of work to use substitution method, because here value of y is not given in terms of values of x explicitly. If you want to use substitution method, you will first have to find out y in terms of x. So y will be equal to negative 4 minus 3x everything divided by negative 2. I'm finding the value of y from second equation, and this will give you 2 plus 3 over 2x, and then you will have to substitute this. I don't know, this I don't feel comfortable with this expression. You will have to substitute this in the first equation. Instead of doing this, here we can use the elimination method. So elimination method says that you have to eliminate any one variable. Okay, so we will try to eliminate any variable. So here what you have to do is you have to make the coefficient. Suppose you want to eliminate the variable x. So what we will try to do is we will make the coefficients of the x variable same in both the equations. So in the first equation the coefficient of x is negative 9. So I will try to make the coefficient of x negative 9 in the second equation as well. So how can I make 3 negative 9? What should I do to 3 in order to make it negative 9? Well, I can multiply it with negative 3, because 3 times negative 3 will give us negative 9. So what we will do is we will multiply this entire equation by negative 3. Multiply this entire equation by negative 3. So that will change this equation to negative 9x plus 6y equals to positive 12. And the first equation was negative 9x plus 6y equals to 12. Well, this is a very special case. You're actually getting both the equations as exactly same. So this is actually the case of infinitely many solutions. Both of these equations will coincide. But let's just assume that instead of this 6 and 12, we have plus 2y equals to 7. Okay. And now you can easily eliminate the x variable. All you have to do is you have to subtract the two equations. So negative 9x minus negative 9x will become, this will become positive, and 2y minus 6y. So what I'm doing is I'm changing the sign of the second equation, and 7 minus 12. Okay, so now this and this get cancelled, so we have eliminated the x variable, and 2y minus 6y is negative 4y, and 7 minus 12 is negative 5. So y is equal to 5 over 4. And in order to find out x, we can substitute y in any of the two equations. I think the second equation looks simpler. So 3x minus 2y equals negative 4. So 3x minus 2 times 5 over 4 equals to negative 4. So 3x minus, well, this will give us 2 to minus 5 over 2 equals to negative 4. So 3x equals negative 4 plus 5 over 2. Well, 5 over 2 is 2.5, so I'm just gonna write in decimals 2.5. So 3x is equal to, now negative 4 plus 2.5 will be negative 1.5, and x is equal to negative 1.5 over 3. Negative 1.5 can be written as negative 3 over 2. So we get negative 1/2 or negative 0.5 as a value of x. So our solution becomes x is equal to negative 1/2 and y is 5 over 4. Alright, so this is how you can use the method of elimination in order to find out your solution. Now another thing is, as I said, types of solutions. Okay, so first let's discuss about types of solution. Now, a system of equations can have 3 types of solutions. I'm going to draw, as you know, a linear equation has the graph of a linear equation is a straight line. So if you have two linear equations, the graph of two linear equations will be two straight lines, and two straight lines can either intersect in a two-dimensional space, or they can be parallel. That means they do not intersect, or they can overlap. They can be on top of each other. So these are the 3 possible cases when we try to draw the graph of two linear equations. Okay, now this type of graph, this is called, when you get this type of graph, then we say that our system of equations is consistent. It is consistent. Even this one is called consistent. And this one is called inconsistent. Now, in this case, you are going to get one solution. So this is the case when you will get one solution. In this case, you will get infinitely many. So this the solution here will be the point of intersection. Here again the solution will be the point of intersection, but here you'll see that there are infinitely many points, you know, because the two lines are overlapping, they are coinciding. So you get infinitely many solutions. Well, basically each and every point which lies on these two lines will be the solution. And in this one, since these two lines are never gonna intersect, so that's why in this case you get no solution. Okay, so the case in which you're getting no solution, that will be inconsistent. The other two cases where you're getting one solution and infinitely many solutions, those two cases are called consistent. Okay, and now what is the condition, what is the algebraic condition to get these solutions? Now let's assume that your system of equations is this: a1x plus b1y equals to c1, and a2x plus b2y equals to c2. Okay, so now in first case, when you're getting one solution, which is the case of intersecting lines, the ratio of a1 and a2 will be not equal to the ratio of B1 and B2. Okay. In the second case, the case of parallel lines, your ratio of A1 and A2 will be equal to B1 and B2, but it will not be equal to the ratio of C1 and C2. And in the third case, where you're getting infinitely many solutions, in that case all the three ratios will be equal. So ratio of A1 and A2 will be equal to the ratio of B1 and B2, and that will be same as the ratio of C1 and C2. So these three conditions are really important, and we're going to use these three conditions to solve the next problem. And SAT math is always gonna ask a question like this, in which it says that for what value of C will the system of equations below have no solution? Okay. So for no solution, what is the condition? For no solution, that means no solution means that these two lines will not intersect. That means they are gonna be parallel lines. And for parallel lines, the condition is the ratio of A1 and A2 should be equal to the ratio of B1 and B2, and this should not be equal to the ratio of C1 over C2. So let's do this. So A1 over A2 gives us C over 3. This should be equal to the ratio of B1 over B2, which is negative 2 over 4. This should not be equal to 6 over 4. And you can easily get the value of C from the first two ratios. So let's just simplify this. This is gonna be negative 1 over 2, and if you now cross multiply, you get 2 times C equals to negative 3, and C is equal to negative 3 over 2. So your value of C is equal to negative 3 over 2. Let's just put C equals negative 3 over 2, and let's just see that this should not be equal to the third ratio. So negative 3 over 2 over 3, this should not be equal to 6 over 4. So 6 over 4 can be simplified to 3 over 2, and this thing is, well, it's negative, so it's definitely not equal to 3 over 2. So negative 3 over 2 times 1 over 3. So this is negative 1 over 2, and negative 1 over 2 is definitely not same as 3 over 2. So the value of C is negative 3 over 2. If C is equal to negative 3 over 2, then this system of equations will have no solution. So that's it for this video, and if you just practice enough questions on substitution and elimination and the type of solutions, then trust me, you will easily get full points and full scores for a question of system of equations. So that's it for this video. I'm gonna see you in the next video, and let me know in the comments if you want me to make any video for any SAT math concept. If you're struggling in a particular concept, just drop a comment, let me know, and I'll record a video on that concept. And if you have any question that you're struggling, if there is any hard SAT math question, let me know, I'll record a video. Till then, all the best for your SAT math. I'm gonna see you in the next video. Bye.